explain working principle of PMMC type relays. So the construction, as you can see in the figure, is similar to the permanent magnet moving coil type instrument. So a PMMC type relay operates on the principle that a current carrying conductor placed in a magnetic field experiences a force. So now this is the permanent magnet. These are two poles. One is the N pole and another is the S pole. So the lines of flux are passing from N to S pole, and this is the moving coil which is placed in between this in a uniform radial magnetic field. So when the relay coil is energized with the direct current, the current flows through the moving coil placed in a uniform radial magnetic field produced by the permanent magnet. Due to the interaction between the magnetic field of the magnet and the field produced by the DC current flowing through the coil. So both these currents or both the fields are interact with each other and produces a deflecting torque in the moving coil. Now this deflecting torque can be found out by the equation, that is TD means the deflecting torque is B into A, that is the flux density into area. So it is nothing but just the flux per pole, number of turns of the coil and current flowing through it. So the torque developed, that is deflecting torque developed in the coil, is B into A, the product, and N into I. So it is flux per pole, number of turns of the coil, and I is the current flowing through the coil. So this is how the deflecting torque can be found out. Now the coil is mounted on a spindle pivoted on the jewel bearings to reduce the effect of the frictions. So the torque causes the coil to rotate with very little friction. Now as the coil rotates, the control spring provides a controlling torque, or say restraining torque, which opposes the deflection. The coil continues to move until the deflecting torque and controlling torque balances each other like this. So both the values are equals to each other. Now when the operating current exceeds a preset value, that is the pickup current, the rotation of the moving coil system causes the moving contact attached to the spindle to close or open the relaying contacts. Thereby they complete the tripping action and controlling action, so that they can give the command to the breaker trip coil or energize the trip contacts. Now when the current in the coil falls below the dropout value, or say resetting value, the deflecting torque decreases and the control spring restores the coil to its original position, or relay comes to its non-operating state. So this is how the permanent magnet moving coil relays operates on the principle of the PMMC type instrument.